Hello, and welcome to Physics 1 Experiment 11, Resonance. For this experiment, we will be studying the phenomena of standing waves on a string and resonance in air columns. You will need the following pieces of equipment: the mechanical driver, the function generator, string with a hanger, slotted masses, the resonance tube, and the oscilloscope. These pieces of equipment will be shown as they were used. Now for procedure A. To start procedure A, we will want to connect the blue function generator box to the black cylindrical wave driver. We will do this by using two banana cables. Once we have these connected, we will suspend the spring on the pulley on the far side of the table and then measure the distance from the top of the mechanical driver to the very top of the pulley. We will record this in our data sheet for the vibrating length of string L. We'll now want to add some additional mass onto our hanger. 100 grams is a good starting point. We will want to make sure to record the total mass, including the mass of the hanger, in our data sheet. We are now ready to turn on our function generator. We can use the two buttons in the bottom middle of the function generator to adjust which digits we are measuring. We will then use the frequency knob to turn down the frequency to a starting value of 20 Hz. We will then use the voltage knob to increase the amount of voltage supplied to the driver to around 5 volts. This number is in the bottom left-hand side of the function generator screen. The mechanical driver should now begin to move and start vibrating the string. Now we are ready to adjust the frequency and look for resonances. You will know you're at a resonance when the waves generated on the string are as large as possible. The humps that are generated on the string are called antinodes, and we will record the number of antinodes that we generate at a certain frequency. We will want to find 3 values for these antinodes and record the frequencies that they correlate to. Once we have 3 different number of antinodes recorded with the frequencies, we will press the standby button on the function generator to stop the oscillations. We will now add additional mass onto the hanger and repeat the process as before, finding the same amount of antinodes as we had previously. There's a good chance that during your trials you will add enough mass to cause the weight hanger to touch the floor. We cannot record data during this, but there is a simple fix. All we need to do is pull the string on the mechanical driver side and wind it around the bracket that holds the pulp onto the table. Please make sure to not change the actual length between the mechanical driver and the pulley. Now our hanger will be suspended in the air and we can continue taking data. Once we have all the necessary data, we can now continue on to procedure B. For procedure B, we will be using the oscilloscope, the big box in the middle of your screen, and the resonance tube, the tube to the right of your screen. We want to start off by unhooking the leads from the mechanical driver and plugging them into the resonance tube. We will now power on the oscilloscope and wait for it to boot up. We can also turn on the function generator while we wait. The black wire that is connected to the oscilloscope is our microphone. This can be plugged into the back of the resonance tube right below the speaker. We will tighten the set screw on the tube to make sure our microphone does not move anywhere. We will then want to check on the microphone and make sure that it is turned on. We can test that our microphone is working by tapping on the table next to the microphone. The line on the oscilloscope should bounce around. Now we are ready to supply voltage to the speaker. We want to set the voltage to around 1 so that it's not too loud. For this procedure, we will be measuring resonance in air columns. A resonance is indicated by the large oscillations on the oscilloscope. As you move the plunger located on the back of the resonance tube, you should notice the waves growing larger and smaller. The largest of these waves is a resonance. Inside of the resonance tube is a meter stick. We will use this to record the position of the plunger whenever we are at a resonance. Please note that each large black tick is 1 centimeter. We will want to record the position of the plunger at 4 different resonances for each frequency. Once we find a resonance, we will want to slowly move back and forth to make sure that we get the maximum size of the waves. We will then record the position of the plunger and then look for another location of resonance. Once we have the 4 positions recorded, we will now adjust the frequency on the function generator to the next one in the data table. We will repeat this process until we have completely filled out the data table. Once we have all the data recorded, we can use the equations provided in the book to finish the lab. Please make sure to turn off every piece of equipment. And that is all. Thank you.